This is standard 8GA3. We're going to describe the effects of dilations, translations, rotations, and reflections on the coordinates of two-dimensional figures that are graphed on a coordinate plane. Now, we've talked about congruence transformations. Now we're going to talk about dilations. Dilations are different from congruence transformations because the figures you get will be similar, not congruent. If you have a dilation, the two figures you will get are similar. That means that they are the same shape, but not the same size. The sides will be proportional. Think of it this way. What if you've got two triangles that are similar? If this triangle size was 1 and this one was 3, let's say this side here was 2 and this one was 6. This side here was 3, and this side here would be, let's see, 9, okay? Notice we have sides that are proportional. These two sides are corresponding. 1 is to 3, as 2 is to 6, as 3 is to 9. If I look at these, all of these would reduce to the same ratio, 1 over 3. 1 is to 3. These two are similar because their sides are proportional. If you have that situation, then the corresponding angles will be congruent. All you have done is you have taken one of the triangles and you have blown it up, made it bigger than the other. So now let's look at some of these that are dilated here. This says we're going to dilate the triangle here by a scale factor greater than 1. That would be 1.5, 2, 5, 1,000,000, whatever you want to dilate it by. Think about whenever you're on a computer and you take a figure and you blow it up. You keep it the exact same shape, but you simply make it bigger. This one says let's dilate triangle PQR. Here's triangle PQR. There are your three vertices, P, Q, and R. We're going to dilate it by a scale factor of 3. That means that each one of these coordinates we're going to multiply by 3. I'll show you that in a second. It says with the origin as the center of dilation. That means we're going to be doing this from here. Whenever you're doing it from the origin, all we have to do is multiply the coordinates by the scale factor. They want us to draw image P prime, Q prime, R prime. So let's do this. Okay, and then list the coordinates. Let's list the coordinates here. Let's start with this. We've got P. Point P is at, see, 1, 3. Okay. If I am going to multiply this by a scale factor of 3, that means that I am going to multiply everything here by 3. And your P prime will be at 3 times 1 is 3. 3 times 3 is 9. P prime is going to be at 3, 9. So let's plot that. Okay, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's where P prime will be. P prime. Now let's take care of R. Let's start with R. Where's R right now? R is at 1, 1. If we're going to multiply this by a scale factor of 3, we're going to dilate it by a scale factor of 3. When you're doing this from the origin, that means you can multiply these two coordinates by 3, and you would get R prime. That's the point it is going to. If you start at R, this is your pre-image point. This is your image point. 3 times 1 is 3. 3 times 1 is 3. So R prime is going to be at 3, 3. So let's find 3, 3. 1, 2, 3. 1, 2, 3. Here is R prime. Now let's find where Q would be. Q starts at 3, 1. If I'm multiplying it by or dilating it by a scale factor of 3, that means I'm multiplying these by 3. That works when you're starting at the origin. 3 times 3 would be 9. 3 times 1 would be 3. Q prime is at 9, 3. So let's go out here to 9 and up to 3. 1, 2, 3. This is where our Q prime would be. Now we can draw our triangle. I'm gonna exchange this for some straight lines. We're gonna do this with some straight lines here. Now let's do a straight line, but let's do it in blue so you can see it. I'm gonna draw the triangle so we can see it. This is what your triangle will look like after you have dilated it by a scale factor of 3. Notice your triangle is 3 times as big as it was before. See how this side is 2? 2 times 3 is 6. 1, 2, 3, 4, 5, 6. This side is 3 times the side it was before. Same here. This side is 2. This side would be 2 times 3 is 6. 1, 2, 3, 4, 5, 6. This triangle is going to, its sides are each 3 times the sides of these here. But what about the angles? Let's look at the angles. I want to make sure you notice this. The angles are not going to change. As we notice, there's a right angle right here. Even though I've dilated this one, this right angle is exactly the same. Whatever the measure is of this angle, it's going to be the same as this one. Whatever the measure is on this angle, it will be the same as this one. Angles don't change when you dilate a figure. What does change is where they're located on a on your coordinate plane. Okay, hold on a minute. There we go. Now it says, explain how you could find the coordinates for triangle P prime, Q prime, R prime without graphing. This is what I did right here. Notice if it said multiply by a scale factor of 3 or dilate by a scale factor of 3, all I did was multiply each one of these by 3. It says write a rule, so let's write a rule for doing that. If we start with xy and we're going to dilate it by 3, I would multiply each one of these by 3, right? 3 times 1, 3 times 3. So when I dilate it by 3, this would be 3 times x, this would be 3 times y. That's whenever you are dilating from the origin. Are triangle PQR and triangle P prime, Q prime, R prime similar, congruent, or neither? If they were congruent, the sides would be the same length. This side is 2, this side is 6. Okay, so I've got 2 to 6. All right, check on this one. 2 to 6, both of those reduce to 1 over 3, or in this case, it would be 3 over 1. Sorry, I should have done it the other way. This one is 3 times the size of this one, okay? These would be similar because the sides are of the same proportion. The sides are proportional, okay? The sides, if the sides were the same, it would be congruent. Now let's look down here. Let's dilate this by a scale factor such that it is between 0 and 1. Our scale factor is between 0 and 1. Our scale factor is a positive fraction. In other words, a fraction less than 1. What if we dilate triangle PQR here by a scale factor of 1/2 with the origin as the center of dilation? So now we're going to multiply by a scale factor of 1/2. We're going to dilate by a scale factor of 1/2. What we should get, since we're doing this from the origin, is we should wind up with a triangle that is half the size of the previous one. List the coordinates for the triangle PQR and triangle P prime, Q prime, R prime. Draw the image after you've dilated it. So I'm going to start with P. P is at 2, -2. It shows me the coordinates on the chart. If I'm dilating my scale factor of 1/2, that means I multiply both of those by 1/2. What do I get for P prime for our image? Half of 2 is 1. Half of -2 is -1. So P prime should be at 1, -1. This is the pre-image, this is the image. P prime is at 1, -1. This is where P prime is going to be. Let's go ahead and plot it. Now let's do Q. Our pre-image Q is at 4, 4. If I want to dilate it by a scale factor of 1/2, I'd multiply both of those by 1/2. half of 4 would give me 2. Half of 4 would give me 2. 2 prime. Our image is at 2, 2. 2, 2. There's Q prime. Now let's do R. R is at 1, 2. If we're going to dilate it by a scale factor of 1/2, we multiply everything by 1/2. And our image, R, will be half of 1, which is 0.5, and half of 2, which is 1. R prime is at 0.5 and 1. See, 0.5 and 1. Right there's R prime. All right, now I'm going to draw the lines between it so you can see what the dilated triangle looks like. Our dilated triangle is going to go from there to there, to that point, and to this point. Notice our dilated triangle is smaller, isn't it? It also moves closer to the center of dilation. Whenever it's getting smaller, it gets smaller. Whenever you dilate it by a fraction that's less than 1, your image will be smaller and it's going to move closer to your center of dilation. Up here, notice when we dilated by a scale factor of 3, our image got bigger and it moved farther from the center of dilation. When we dilated it by a scale factor that's a fraction between 0 and 1, the image got smaller. It's half the size it was before, and it got closer to our center of dilation. Now, what if we dilate by a scale factor of 1? Oh, wait, it's going to ask us, was our triangle similar, congruent, or neither? It's similar. It's not congruent. They're not the same size. They are proportional. Their sides are proportional. So this would be similar. Anytime you have a dilation, you create similar figures. What if I dilate by a scale factor of 1? We've talked about dilating by a scale factor of greater than 1. That meant we made a bigger figure, same size, same shape, different size. We dilated by a scale factor that was a fraction between 0 and 1. I made it a smaller figure. They're still similar, same shape, just smaller. Now let's dilate by a scale factor of 1. It says dilate the triangle shown by a scale factor of 1. With the origin as the center of dilation, we're still using this as our center of dilation. Are the pre-image and image triangles similar, congruent, or neither? Well, let's look at our points here. This point is at 6, 6. So I've got a point at 6, 6. I don't have a name for the points. Okay. I'm going to dilate at 1, so I just multiply everything by 1. I wind up with a point 6, 6. Gee, that's where I started, wasn't it? Now let's look at this point. It's at 3, 9. What if I dilate 0.39 by a scale factor of 1? I come away with 3, 9. We are at 3, 9, where we started. How about this point? This is at negative 3, 3. Negative 3, 3. If I dilate it by a scale factor of 1, I wind up with negative 3, 3, what I started with, right? So when you dilate it by a scale factor of 1, we don't change this triangle at all, do we? We have the exact same triangle that we had before. Nothing has changed, okay? Think about this. When we dilate by a scale factor of 1, nothing changes because we multiply all of our coordinates by 1, nothing changes. When we dilate by a scale factor that's a fraction between 0 and 1, we're making it smaller, half the size of what it was to start with. The figures are similar. If we dilate it by a scale factor that's greater than 1, in this case it was 3, we make the figure bigger, move it farther away from the center of dilation. Okay? Now, back down here to the dilating by a scale factor of 1. Are these two similar, congruent, or neither? Well, they're similar because their sides are proportional, but their sides are proportional in 1, so they're congruent. So they're congruent and similar is what you're dealing with. They're congruent and similar. Now let's look at the other type transformations. All of those were dilations. Those were not congruence transformations except the dilation by 1. Let's look at those that are always congruence transformations. Let's start with translations. This has to translate this triangle ABC 3 units right and 2 units down. So let's do this. Every point we go 3 units right, 1, 2, 3, and 2 units down, 2 units down. If this is A, this is our pre-image. Our image after we've done the transformation is A prime. And on this one, 3 units right, 1, 2, 3, 2 units down, 1, 2. That would be B prime. See, we started with B, that was our pre-image. Here's our image. Pre-image just means where we start, image is where we end up. C, 3 units right, 2 units down. And so this would be C prime. What I have done is I have simply moved this figure over, translated it, which means you move it over. Oops. Go back to, we'll get our point here. And I'm drawing the triangle now so you can see it. Notice these two figures are congruent. I could map this one back on top of that one, or I could map this one over here. If I can place them on top of each other and they're exactly the same, corresponding angles are the same, corresponding sides are the same, then they are congruent. We've graphed that triangle. Provide a rule that could be used to find the coordinates for this translation. Okay, let's try that. What did we do here? We started, let me get us a pen. We started with XY. And what did we do? Let's look at A and A prime. A is at 2, 5. And we went to A prime. A prime is at 5, 3. What did I do to get from 2 to 5? What did I do to X? Didn't I add 3? 2 plus 3 gives you 5. Okay, on Y, what did I do? I went from 5 to 3. I subtracted 2, didn't I? Doesn't that make sense? If I'm going 3 units right, I'm adding 3 to whatever the X value is. If I'm going 2 units down, I'm subtracting 2 from whatever the Y coordinate was. So here's the rule that I could use. This is our rule. I start with XY. I add 3 to the X. I subtract 2 from the Y. And that gives me my image. Provide the coordinates for the pre-image and the image. Let's see. We did A. Let's look at B. B was at 4, 2. And B went to, what was B prime? B prime, which was 7, 0. Doesn't that make sense? I added 3 to the X, subtracted 2 from the Y, right up here. And then let's look at C. On C, I started at 1, 3. And my C prime is at 4, 1. Well, let's look and see if we did exactly what we said we did. X plus 3, 1 plus 3 is 4. Y minus 2, 3 minus 2 is 1. Okay, and then it says, are the pre-image triangle and image triangle similar, congruent, or neither? These are congruent. That means they're similar and congruent. Okay? They're similar because they have a scale factor of 1, right? They're congruent because they're exactly the same. Let's look at what we can do with a rotation. It says rotate triangle KLM 90 degrees clockwise around the origin. Okay, if I'm going to rotate this, the first thing I'm going to do, usually you would do this with tracing paper. I can't really show you tracing paper on here. So what we're going to do is we are going to use our straight line here. We're going to go from here to the center of rotation. You're always rotating around something. Usually it is the origin. Okay, so I want a line that's the same length, but is at a 90-degree angle. It's going to be up 1 over 2. So let's see, but I need it to be a 90-degree angle, don't I? That's where it would be. Oops, that's where it would be. It's right there. Okay. M prime is going to be right there. Okay. Now, notice, let's first look and see if we can find a rule here, because we need all the coordinates. M, what is M at? M is at -2, 1. -2, 1, yes, okay. Let's see what it went to. Let's see what M prime is. M prime is at 1, 2. 1, 2. Okay. They want us to have a rule for this, so let's see if we can do a rule for this. It might be easier to do this right here, and then we can find our other points. We started with an XY here, didn't we? To get from -2 to 1, I could add or something, but usually when you're doing a rotation, you're moving your X's and Y's around. Look, this was the Y. I'm putting the, this was the X. I'm putting the X where the Y was, and I'm changing its, I'm changing it from positive to negative. So what I do here is I start with XY. I take X, I move it to the Y spot, and I change it from positive to negative. And the Y becomes in the X spot. Okay, there's my rule. Can we do this for each one of these? Let's try doing this for each one of these. Okay, the K. Our K, let's bring it down to the center, and let's find where it would go. And we need something that is at a right angle there. It's going to be out 4 and 8. So 8 and 4, is that it? That's our right angle right there. Okay, see how that right angle is formed there? Let's go ahead and put that one in. Our K went from -4, 8. It went to 8, 4. Let's see if it fits our rule. We swap the X and the Y. See, we swap the X and the Y, and on the back one, we changed its sign. It was -4 here, it's +4. Can we do the same thing for our L? Let's see, our L starts at -4, at -7, 4. Our L prime then is, see, we swapped our X and our Y. 4, 7, and which one do we change the sign on? This back one. So this was a -7, it's going to be now +7, okay? Are the pre-image triangle and the image triangle similar, congruent, or neither? Well, if we actually plotted this out, 4, 7, 4, 7. If you plot this out, what you're going to see is that your image triangle and your pre-image triangle are congruent, and that means they're also similar with a scale factor of 1. Now let's look at reflections. If you reflect, when you reflect something, you have to say over which axis. Okay. Oh, wait, one thing on rotations. Whenever we rotate, we've got to say how we're rotating. We said 90 degrees clockwise, that's here. 90 degrees means that you're going one quadrant, okay? 1/4 turn all the way around, one quadrant. Because think about it, if you go all the way around a circle, it's 360 degrees. If you divide that into 4 parts, each one would be 90 degrees. So what you've done here is you've gone 90 degrees. You form 90-degree angles here on each one of these pre-image and image lines. Now, reflection. What if we reflect over the x-axis? It means you look at your x-axis and you're trying to figure out how many spaces you are away from the line of reflection, which is your x-axis. In this case, I'm 2 points away from it, so your r prime is going to be right here. 2 points on the other side. You could fold the paper over the x-axis too and get the same results. Your q is, let's count, 1, 2, 3, 4, 5, 6 above. Q prime is going to be 6 below. 1, 2, 3, 4, 5, 6. There would be your q prime. Your P is 1, 2, 3, 4, 5, 6 above, so it's going to be 6 below. 1, 2, 3, 4, 5, 6. There's your P prime. Your triangle would look like this. Notice, if I were to fold this line right along x-axis, these two would map right onto each other, and you could prove that they were congruent. That's a reflection. What if you reflect over the y-axis? Let's see what happens. When your y-axis is where you would be folding it, count to your y-axis. This P is 2 points from it. It's going to be 2 points on the other side. That's P prime. Q is 1, 2, 3, 4, 5, 6, 7, 8 points from it. 1, 2, 3, 4, 5, 6, 7, 8 points on the other side. And R is 1, 2, 3, 4, 5, 6, 7, 8 points here. 1, 2, 3, 4, 5, 6, 7, 8 points over there. There's R prime. P prime, Q prime, R prime. And the triangle you get after you reflect over the y-axis looks like this. Okay? If you fold it along the y-axis, these two would map right on top of each other. Now let's look at the questions we've got. We've graphed the two triangles. Provide a rule that could be used to find the coordinates for this reflection. Well, let's just find the coordinates, and then we should be able to do it. The coordinates for P here, P is at 2, 6. P prime, let's see what P prime's at. P prime is at 2, negative 6. Where's Q? Q is at 8, 6. Q prime is at 8, negative 6. And R, let's see, R is at 8, 2. R prime is at 8, negative 2. What have we done here on each one of these? In each case, the x has not changed. All we've done is change the positive or negative sign on the y. So a rule here would be you start at xy and you go to x opposite of y. Okay? Are these images similar, congruent, or neither? Well, if you folded those, they'd be right on top of each other, so we know they're congruent, and they're similar with a scale factor of 1. Let's look at this one here. Our coordinates. Our P here was at 2, 6. And what's our P prime at? Let's look at it. P prime is at negative 2, 6. Our Q, let's see where Q is. Q is at 8, 6. What's our Q prime at? Q prime is at negative 8, 6. And let's look at our R. R is at 8, 2. What's R prime at? R prime is at negative 8, 2. What's changed here? Well, let's look at this. The y stayed the same in each case, didn't it? It didn't change. The x, however, has gone from being positive to negative. So we have the x opposite on the x, but the y doesn't change. You start with xy, and your rule would give you, I'd keep my x. Oh, no, no, no. I'd be the opposite of my x, and my y doesn't change. Okay, perfect.